Suzanne Borders, and I am the CEO and founder of BadVR. Today I'll be talking about using immersive technology to visualize climate change. So a little bit about me. For the past 8 years or so, I've been leading the design of 2D data analytics products for companies such as OSERV, Remind, and Crexi. My company, BadVR, has received several SBIR Phase 1 grants from the government, including from NOAA and the National Science Foundation. Lastly, in 2019, I was named an IEEE Entrepreneurship Rising Star. Down here at the bottom, you can see my Twitter handle. I encourage you to follow me. I discuss all things related to immersive technology, data visualization, and the intersection between the two. So the problem that we're facing today is that it's incredibly hard to condense down 1 million or more individual data points into one decision or insight. As you can see here on the left side, this is raw data. And on the right side, these are the 2D data visualization methods that we're currently using. They're highly reductive and only give us one vantage point into very complex multidimensional data sets. So I, like Edward Tufte, believe that we shouldn't abbreviate the truth that's hidden within these data sets by using these reductive visualization methods, but instead we should find better methods of presentation. So, as you can imagine, I believe the solution lies in immersion. And when I use the word immersion, I mean augmented reality, virtual reality, spatial computing, and everything that runs the gamut of what could be considered extended reality. So on the slide, you can see this picture. It's a sculpture by Bernard Praz. The story of this sculpture changes depending upon viewpoint. So from one angle, it looks like a masterpiece, and from another angle, it looks like a total mess. Well, the same is true for your data set, and consider 2D visualizations as one vantage point into a truly multidimensional object. So in the current method, you would have one method or one analysis that says there's no insight, and another analysis that would say there is an insight. But the reality is that both are true, that from one vantage point, there is no insight, but from another, there is. The only way to really achieve a full understanding of this piece of art or modern multidimensional data sets is to experience the thing multidimensionally. As you can see here on the slide, on the left, we have a 2D standard visualization of climate change data. And while this looks compelling and even beautiful, it's really difficult to understand, especially so for non-technical users or for people not trained in how to read charts such as these. So while it may capture people's attention, it's really difficult for them to extract the insight. Versus on the right side, we have an immersive display that as soon as you put on the headset, the user can see the data in a way that makes sense to them, that's contextual to their own environment or to their city or to an environment that they're familiar with. And they can easily and quickly get to the insight hidden within that data set or those data sets. So the benefits that are offered by immersive technology that my company has discovered is overall it makes these data sets far more accessible, which is incredibly important when it comes to climate change. We want everybody to be able to understand the importance of climate change, which then, of course, drives them to action to help solve the problem of climate change, which leads to higher empathy and engagement. Immersive technology brings these data sets home, and really the presentation makes users have a much higher empathy with those affected by climate change and a much higher engagement with the data sets overall. It also gives users greater context, and like I mentioned, achieves faster insights, allows them to view 1,000 times more individual data points in a single viewpoint, and adds an increased mobility to the data. All of this processing and visualization can be done on mobile headsets and even mobile phones. And of course, geospatial data, it makes sense to display it geospatially. That's the way the data is captured. That's the way it is best visualized. So how this technology works is we take multiple large complex data sets and project them into a multidimensional space. And using augmented reality, we project it onto the user's own environment. With VR technology, we provide a replacement virtual world in which the user can navigate through these data sets in real time, viewing real-time data feeds and interacting using controllers and gestures. Some of my company's current projects include work with the UNDP, the German Aerospace Center, NOAA, and Magic Leap. We're visualizing weather, city, and environmental data. As I said, AR, using AR or VR, and even mobile phones that have AR capacity. We're providing real-time solutions for pilots and first responders who are fighting against the impact of catastrophic weather events caused by climate change, and also providing historical data displays for policymakers and politicians who want to understand how these data sets are affecting their local populace. So let's jump into some quick concepts and use cases. What you're looking at here is a remote communication collaboration tool that allows scientists and researchers to view data feeds from an area highly impacted by climate change and then communicate those insights amongst each other, whether all being in the same location or in different locations. This is a real-time climate simulation of rising sea levels, where users can put on a headset and see how rising sea levels would immediately impact their own environment. We have a weather and environmental data overlay. This one hits close to home for me, being a Californian. We have a lot of wildfires. And in this instance, users can put on a headset and view real-time data about the wildfire, whether they're down on the ground being firefighters or whether they're up in the sky as pilots. They can understand what's happening with the fire and respond to it in real time. So lastly, we cannot solve our problems with the same thinking that we used when we created them. 2D data visualization methods are from the past, and they worked really well when data sets were small, when they were not as complicated as they are now. But as we move forward into the future and we face new challenges with climate change, we're also going to face new challenges with the scale and complexity of the data sets that define these define them and visualize these climate change effects to us as humans. So I also, like Albert Einstein, believe that we have to come up with new ways of thinking and new ways of working with and understanding these modern climate change data sets. And in my opinion, immersive technology offers an amazing way to do this. My name is Suzanne Borders. Again, I'm using immersive technology to visualize climate change. Thank you for your time, and I look forward to your questions.